Hello once again. So this is your Sir Joseph, and I'm here right now recording this presentation so that you'll have something to work on even if I'm not there. Now, if you haven't covered part one of this presentation, which is integration by partial fraction decomposition, case one, you may go back to the first video that I made that I published, I think two days ago. So that video was downloaded by your proctor. So if you haven't covered that yet or haven't watched that yet, uh, pause this video now and go back to that video and watch that first. If not, then we'll move on. Okay, so before we begin with a new case of integration by partial differentiation, I want you to be able to evaluate the integral of 1 over x squared minus a squared with respect to x. So here a is treated as a constant. And of course, given na yung answer nyo is 1 over 2a ln of the absolute value of x minus a over x plus a plus c. So this is not really a problem, but I want you to work this out with your classmates and your proctor. So you can pause this video here for 5 minutes and work on this problem. Okay. Now if you're done, let's just review some of the derivatives that you covered back in Math 5. These are the derivatives of the inverse trigonometric functions. So you learned that the derivative of sine inverse of the inverse sine of x with respect to x is equal to 1 over square root of 1 minus x squared. And then the derivative of inverse cosine of x is with respect to x is equal to negative 1 over square root of 1 minus x squared. And take note that they only differ by the negative, okay? Oh, by the negative symbol here. And then the derivative of tangent inverse of x is equal to 1 over 1 plus x squared. Now, note that here, if we get the integral of 1 over 1 plus x squared, we should be able to get the inverse tangent of x because that's how we define integration back in our first day submitting. And of course, if you get the integral of 1 over square root of 1 minus x squared, then we will get sine, the inverse sine of x. So now we can generalize this now into formulas. Okay, so the integral of 1 over square root of 1 minus x squared dx is equal to inverse sine of x plus c. The integral of 1 over x squared plus 1 dx is equal to the inverse tangent of x plus c. And finally, 1 over x squared plus a squared dx is equal to 1 over a inverse tangent of x over a plus c. Alright, now that we are done with this, let's move on to the second case of integration by partial differentiation. Now, in our previous video, we showed that if the factors are linear factors and there are no repeated factors, that is, each linear factor is unique, then we can write the partial fraction decomposition as a sub 1 over a sub 1 x plus b sub 1 plus a sub 2 over a sub 2 x plus b sub 2 plus and so on until a sub k over a sub kx plus b sub k. But in some cases, there are linear factors that are repeated. Let's say r times. So r here stands for an integer, say 2 times, 3 times, alright? So, for example, we can have a sub 1x plus b sub 1 raised to r. So this occurs in the factorization, say, for example, of q of x. So we have a factor a sub 1x plus b sub 1 which occurs r times. Then instead of single terms a sub 1 over a sub 1x plus b sub 1, we would use this expression here. Okay, so here you can see that this linear factor is also the same as this linear factor, but this time it's raised to the second power, and you keep adding terms, okay, up to a sub r here. Okay, so replace 1 here by r. Okay, all over a sub 1x plus b sub 1 raised to the rth power. So let's illustrate this with a specific example. Here we have x cubed minus x plus 1 over x squared times x minus 1 cubed. Okay, so you can see here that we have two linear factors that are repeated 2 times. So here we have the linear factor x, it's repeated 2 times, so x times x. Here we have the linear factor x minus 1 repeated r times, that is x minus 1 times x minus 1 times x minus 1. Okay, so according to our form here, we have to expand this as a over x plus b over x squared. Okay, so that these two terms here take care of our x squared here in the denominator. And for this repeated factor in the denominator, we have c over x minus 1 plus d over x minus 1 squared plus e over x minus 1 cubed. Okay? So, ganito natin gagawin kapag meron tayong repeated na linear factor doon sa ating denominator. Okay, so if you don't have any more question about this, we can move on to the next slide. But if you do have a question, please pause this video at this point and ask your proctor. Alright. So, let's have a simpler example to illustrate our point earlier. Okay, so here we have an integral of x to the fourth minus 2x squared plus 4x plus 1 all over x cubed minus x squared minus x plus 1 with respect to x. Now take note that this is an improper rational function because the degree of the numerator 4 is greater than the degree of the denominator, which is 3. So once again, what do we do if we have an improper function? Yes, that's right. We take care of the improper fraction by dividing the numerator first by the denominator until we get a remainder whose degree is less than the degree of the denominator. Okay, so just like this. Okay, so x to the fourth minus 2x squared plus 4x plus 1 divided by x cubed minus x squared minus x plus 1 is equal to x plus 1 plus 4x over x cubed minus x squared minus x plus 1. Okay, so you can verify this on your own. If you like, you can pause this video and do that right now. You can do this for, I think, 2 minutes. Okay, now if you're done, let's move on. It's actually easier to factor q of x equal to x cubed minus x squared minus x plus 1 by looking for the looking for zeros of the function, as you have learned in your elementary algebra. Now notice that q of 1 is equal to 0, which means that x minus 1 is one of the factors of q of x. Now, that we can factor now that upon factoring x minus 1, you see that the other factor is x squared minus 1, and we know already, or we are very familiar with this form of the polynomial, and we know that this has factors x minus 1 times x plus 1. Oh, this is wrong. So the parenthesis should be here and not there. But anyway, the answer here is correct. We have two factors which are x minus 1 and x plus 1. So x minus 1 is repeated. So you know where this is going already. So na-imagine nyo na ito ay mauulit. Okay? So since the linear factor occurs twice, x minus 1 occurs twice, the partial fraction decomposition is 4x over x minus 1 squared times x plus 1 is equal to, okay, so a over x minus 1 plus b over the square of x minus 1. Now, we stop here because the exponent here is 2, so we end at 2 here, plus c over x plus 1, which is the other factor. Okay, so what's next? Right, we multiply each side of the equation by the greatest common denominator, which is x minus 1 squared times x plus 1. So we don't have to multiply by x minus 1 times x minus 1 squared because that becomes x minus 1 cubed. So we don't want that. So the greatest common denominator is, of course, the denominator here, which is x minus 1 squared times x plus 1. So if we do that, we end up with 4x is equal to a times x minus 1 times x plus 1 plus b times x plus 1 plus c times x minus 1 quantity squared. Now take note that we can expand each of these expressions and combine the like terms to get a plus c squared x squared plus b minus 2cx plus negative a plus b plus c. Equating the coefficients, a plus c is equal to 0 because there's no x squared term here on the left, so we have a plus c is equal to 0. B minus 2c is equal to 4 because x here has a coefficient 4. And finally, negative a plus b plus c is equal to 0 because we don't have a constant term here on the left. So solving for a, b, and c in this system of equations, we get a is equal to 1, b is equal to, and c is equal to negative 1. Of course, you can also use the technique that we used before, which is to substitute a value of x that will simplify the expression. For example, if we substitute x is equal to 1 here, then this term vanishes, and we have b times 1 plus 1, so that's 2b, is equal to 4 times 1, and we end up with 2b is equal to 4 or b is equal to 2. If we substitute x is equal to negative 1, this term vanishes, and this term becomes negative 1 minus 1, which is negative 2. The quantity squared is 4, so we have 4c is equal to 4 times negative 1 is negative 4. So 4c times negative 4, or we have c is equal to negative 1, which is this equation here. Now, of course, we cannot solve for b since if we substitute, of course, we know already what the value of a here and the value of c there. So if we substitute, let's say, another value 0 here, we'll now get negative 1a plus b plus c is equal to 0. So we can now substitute the values that we derive for a and c and solve this equation here for b. And we get, oh, sorry. So what was that again that we did not solve earlier? Oh, yeah. So if x is equal to 1, this one vanishes and this one vanishes, so we solve for b. If x is equal to negative 1, this vanishes and that vanishes. Also, a is what remained to be solved, so we substitute b is equal to 2 here and c is equal to negative 1, and we get a is equal to 1. So going back to the original equation, here we substitute a is equal to -1, b is equal to 2, and c is equal to -1 here. So we now get okay, so from the original equation we now get x plus 1 plus 1 over x minus 1 plus 2 over the quantity x minus 1 squared minus 1 over x plus 1. So this integral is equal to this integral, and we can now do term by term integration. Okay, so we have x squared over 2 plus x plus ln of the absolute value of x minus 1 minus 2 over x minus 1 minus ln of absolute value of x plus 1 plus c. So take note here that you can use integration by substitution to take care of the term x minus 1 in the denominator. Take note that u is equal to x minus 1 and not x minus 1 squared. Simplifying this expression, you can see here that we have an expression ln here and an expression ln there. This one is positive, and that one is negative. So ln of absolute value of x minus 1 minus ln of absolute value of x plus 1 can be combined into ln of absolute value of x minus 1 over x plus 1. So we now write the final answer, x squared over 2 plus x minus 2 over x minus 1 plus ln of the absolute value of x minus 1 over x plus 1 plus c. Now here take note that traditionally when there are terms that can be simplified or combined so that the number of terms can be diminished, they are combined, okay, to simplify the expression. So in this case we can combine this term and this term to have this term here. Okay, so I guess we'll end our discussion in this lecture for case number 3. For case number 2, and then perhaps tomorrow we will cover case number 3 and case number 4. Okay, so for now, what I want you to do is to work on the worksheet that I'm going to send your proctor for today, and I want you to work again as a group, and if you don't understand anything, just consult your teacher for the day. So yun lang muna, class, and I hope nag-aaral kayo kahit na wala ako dyan. So I'll be back next week. Hopefully wala muna akong travel na susunod after this. So if you have some questions, just throw them to your teacher, and then I'll see you soon. Bye.